Jake, how are you doing? I'm Jonathan.
Hello Jonathan,
Nice to meet you. I'm very well, thank you. Thanks so much for inviting us to 3D to the Lenticular Europe. Is it possible we could start off by looking at some of your previous work?
Yes, we have some just over here, ready for you to see.
Great. So what have we got here then?
Right Jonathan, we've got Step Up 3D. This is the latest poster that we've produced for Universal Studios Touchstone Pictures. Okay. We've commissioned it. This is a current release at the moment on the cinemas. So look at this.
That's amazing. This is coming out. The Step 3D is coming out, and they've also got. Well, they're sort of going in and out. How on earth did you manage to do that?
Right. Well, this was a 3D conversion. I didn't have the luxury of a 3D photograph on this, so we had to actually basically. Put depth perspective into the image itself,
okay.
Which is quite a long and laborious process of using computer graphics and morphing technology to actually bend the image, and a lot of just plain Photoshop actually, just simple hard work.
In terms of what the client gave you, you would just be given a single image? Or?
Yeah, so I was given a flat image but with layers, fortunately. Okay. This makes life a lot. I mean, most graphics now come in layered form, so. For example, I would have the logos would be in a separate layer.
Like a Photoshop layer?
That's right, yeah. Photoshop layers, and the characters here were in layers. If they're not in layers, then they have to be cut out so that I can turn them into layers.
Okay.
So I usually nowadays we tend to get them in layers. We're going to pitch the lens now. This is a 15 LPI 3D lens, which is bought from my supplier in America. It's made of Perspex, this particular sheet. It's quite thick, as you can see. We're going to synchronize it with the print. We're going to use what's called a pitch checker, which is a series of bands which change from 100% to 99% in 0.1 increments. In fact, in 20 steps, actually. So we're going to pop this on. And you'll see straight away that we get some patterns like this.
Okay, yeah.
Like that. And we take it up so that we get a vertical pattern, and then we move it over a bit. And what I do is I climb the ladder to get to the desired height of viewing, the correct viewing distance which we decide to be. I look basically down on it, and then I just move left and right until I can see one of the bands becoming clear or black. And in this case, the black band, the band that's snapping correctly or flipping correctly, is 99.35.
So basically, the process was that you know the right pitch you're using, and then this is something you would now put into Photoshop before you print out, and then it's going to match the lens or lenticular lens, yeah.
So 6502, and then we do a calculation. It's a simple calculation multiplied by the pitch, which was 99.3%. This gives us a new pixel width of 6456. So 6456. That's our new pitch. As I say, it has to be exposed by the laser system, which exposes it one pixel at a time, okay, in a line basically, and it moves along and sweeps the entire sheet of paper with laser light, and that will form a colour image into the emulsion, which will then be processed, and then we'll see it. It works in a gigantic way like a Boots Photo Lab does when you send your digital pictures in for printing. So it's, as I say, it's nothing like inkjet printing, but it's much faster. So I'm just going to take it out of the machine, and we're going to put it through the processor. Right.
Right. So there it is in 2D.
Yes, you can see it's a photographic print, an encoded photographic print. So all this 3D information is locked up into these lines. All of them, and you can see quite clearly. So it's just a flat print, and the magic will happen when we put the lens on it. The lens will decode the image and will fire the respective lines into your eyes to give you a stereoscopic image, like so. And then once you put the lens on, it ceases to be blurry and starts to become an image. So we'll be very carefully now, lift that up, and we'll move it. Just brush off any dust. Move it over to the laminator now. This is, as I said, this is what makes the process expensive, because if this goes wrong, we have to start all over again.
So when you did Step Up 3D, you were doing this 350 times?
That's right, yeah, but we did get pretty slick at it. It needs to be a constant motion. You can't stop once you start, because if you stop, you'll get a line.
So once you're committed, you're committed.
Yeah, basically, yeah. So that just dropped off like that, so we don't really want it to stick the laminate, and we can just
well caught.
gently pull it back. Okay.
Wow!
Look at that.
Look at that. That's absolutely awesome.
And that was in one take.
Good grief! That, I mean, I'm hoping that I think it is coming across on lens actually.
You see that?
Yeah.
The lens itself focuses light from a particular point. We're going to try and demonstrate it in reverse with this laser beam, which I have a beam here. And we can see that the beam coming in is actually being focused onto one pot here, where my thumb is, there.
Yeah.
It's being focused onto one spot.
Sure.
You see?
Yeah.
Now that one spot represents one part of the image in reverse. Now if we put a spot here, it will only be seen where that beam is actually. Your eye would represent the direction of that beam.
Right.
And so your eye will only see that one spot. If we move the spot over, it'll be seen in a different place. So this is how the lenticular works. It focuses light from one spot outwards and then projects it in a beam effectively. And each lenticule does exactly the same thing. So that we see one part of the image on one lenticule, and it will build up over all the lenticules, you see.
Have you noticed a change in your clientele since the boom, or not? Are you having the same kind of customers, because you sort of do quite bespoke work, don't you?
It's definitely improved since 3D television. 3D cinema has finally come of age, and it's only come of age again through the digital realization, which has made it much simpler to actually put a three-dimensional movie together, whereas in the past it was bespoke work. You had to have especially built projectors and things. Now it's actually sitting on the back of technology that's been around for quite a long time. There's nothing intrinsically new about it. In terms of it improving my personal work, yes, it has, yes, because up until recently I wasn't getting a lot of 3D stuff. I was getting a lot of flip stuff, which I was just demonstrating to you earlier, and some animation. But now people are seeing 3D movies. They want 3D posters to go with the 3D movies. So we're seeing a bit more of that.
Okay. Well, I'd just like to focus on the practicalities of producing a 3D print. I mean, we've got one here. Did you actually take a picture of this yourself, or was this
that's correct. No, that's
conversion?
Yes.
So if you're taking a picture of anything, I mean, you can see this is the one we saw earlier, one of the... is that tulips?
Yes, these are tulips in Holland.
Holland.
One of the many farms where they grow tulips.
And so, can we just quickly go through the process of taking? You want a 3D lenticular print. Let's say you want a stationary image. I'm sure they weren't stationary because of the window, but you want a stationary image. How many shots do you have to take? Do you have to take them with one camera, or it has to be at the same time?
I'll
Or
reveal a little secret on this one. This was actually done with a Canon EOS digital camera on burst mode. Now, what we do is you can set the shutters just to continuously fire, and it will give you about, this particular camera will give you about 9 shots before it runs out of memory. And basically, you just got to hold the camera and focus on, just basically center on one part of the flower, and you press the button and you just move it with your hand like that. You just do a hand scan. And if you do it 3 or 4 times, one of those will be smooth enough to use. Okay. And so that doesn't require any fancy 3D equipment. You're just using an ordinary camera. With digital cameras, it's getting much easier now with this burst mode.
So have we reached a sort of a pinnacle now of where we can take lenticular technology?
I think there's some room to go. Yeah, it very much depends if we're going to stay with the LCD system or move on to OLED or discrete LEDs, because we're already using discrete LEDs for photographic printing, where we can get 300 LEDs to the inch, which is very fine. Now we only need to be able to get tricolour LEDs into that space, and then we've already got a pretty impressive display medium. I can't imagine it being cheap for quite a long time though. Maybe it's practical for small displays where you won't need such a huge array.
Right.
But to get a matrix of LEDs that could yield maybe at least say 150 pixels per inch, you could then use a lenticular lens on that and have quite an effective 3D display. But they're already doing it, but they are compromises at the moment. They're not really there yet. What I'm hoping to get in the near future is to actually go backwards a little bit and start using, because I bought a traditional camera, a 3D camera, a very large format 3D camera, which this goes back to say the 1930s, this technology, and I've got a modern variant of it which is just coming over at the moment, and so I hope to be able to do some really beautiful 3D portraits, maybe of famous people and celebrities and things like that, to do something, because these will be really special.
Really?
They'll be really special, yeah. But that's something. But ironically, that's an old analog process. That is a film-based process. It's not a digital one. But what I do is I use scanners here to scan the original master negatives in, and then I can manipulate it digitally, and then make the prints as before. I can guarantee with this camera, no one will be doing this kind of work. This will be absolutely brand new for the 21st century.
If you want to know some more information, what is it? It's lenticular-europe.com, or there's jakepurches.com, but lenticular-europe.com is probably the best website to go to. So go to that website to find out more about Jake and there's some stories there about his previous work as well. And I hope you've enjoyed it, and I look forward to seeing you again soon. Thank you.